Hello and welcome to the review part 2. Okay, so let's get started. This is a discrete probability. Okay, we call these probability tables sometimes. Discrete probability. These are random variables and these are the probabilities of the random variables. Okay, so we need to find the mean. And there is a way to do this in StatCrunch. Okay, but let's go ahead and do it by hand first. So it's going to be you need to multiply these because these are weighted. Each one of these are weighted. See, two is weighted the most. Okay, on average, well, if you looked at this, you'd say, well, most people tended to have about two TVs. Over half the people had two TVs, so that needs to be accounted in the weight. So you just multiply them and then add them all together. Okay, and the standard deviation, what we want to do is we want to find the distance away from whatever this mean is. Okay, so it's 1 minus, I'm not sure what it is, I didn't figure it out, and then times it by it. Okay, and then add, so I take the variance away from the mean there. Okay, and then I do the same thing with 2, whatever this number is here, square it, multiply times 0.51 plus 3 minus whatever we got up top here, square it, multiply it times that. Sorry about that. Parentheses on one side. 4 minus, this is the, and I just take the square root of this whole thing. Okay, so let's go ahead and do this on StatCrunch. Okay, so let's go ahead and enter our numbers in one list. And then scan over here and put our probabilities. Oops. Sorry about that. I'll fix that in a sec. 512 and 0.05. Okay, and what we want to do is we want to go to Stat. We want to go to Calculators. We want to go to Custom. Not that. Must have hit something. Stat, Calculators, and Custom. Now we want to display the mean and the standard deviation. Say OK. I didn't put my variable, so I want to put variable 1 here. My weights, these are my weights, and variable 2. And okay, so the mean is 1.9 and the standard deviation is about 0.8. Okay, so let me move that. So the mean here, it disappeared on me, was 1.9 and this number was 0.8. Okay, so they'll say, what's the probability of, oh, I just did the mean and standard deviation. I didn't even need to know that. Okay, so this might go for the next one. What I did was I found the mean. I found the mean and standard deviation. Okay, so we probably just did the next page. But anyways, let's do this one. What is the probability? What's the probability that x equals to 3? So that means that I own 3 TVs. So all you have to do is go to 3 and just scan down. These are all my outcomes, and these are all the probability of those outcomes. So it's that easy. Okay? It's that easy. So I could say, what's the probability of owning at most 2? At most 2. So I want 1 and 2. I just sum them up. Just add them up. Okay? That's it. Okay, so I think I have this page and the next page done. Let's see. Oh, okay, they didn't have us under that. I thought that was somewhere. Okay, good. Binomial. If you remember, binomial has 4 things. There's a success or a failure. The probability of success is the same. is the same for all trials. They have to be independent of each other, and they have to be finite trials. Those are the 4 conditions to be a binomial. Okay, so in a survey, 75% of students said the courts show too much concern for criminals. We want to find the probability of showing too much concern would be a success. That's the success. A failure would be, if this is showing too much concern, a failure would be the complement of that, which would be not showing concern. Okay, so what's the probability of success? What's the 75% of the students said that there's too much concern? So that would be 75%. So 75% of the people showed there was too much concern, and you have 25%. So then the difference of those, see, is 25. See, complements are pretty easy for binomials, because if you have P is the probability of success, then the complement of that is the probability of a failure. Okay? If you have n trials, then we expect n times p successes. For example, let's say I had 200 people here. I would say, how many do I expect to say shows too much concern? If I had 200 people, how many do I expect? So for every 100 people, if the probability that they're going to say too much, the probability of success is 0.75. So every 100 people, I have 75. So if I had 200, that would be 150, which is 200 times 0.75. If you run this number, you should get 150 people, which is the mean of a binomial. Okay, you see how much easier it is to do? You see how much easier it is than to do this one? We had to do all this work. Okay, for the binomial, if you know it's a binomial, it's really easy. You don't have to go through all that stat crunch thing. You just common sense, which we're going to be doing here on the next page, mean and standard deviation. Okay, so for the mean and standard deviation, or for the binomial, I'm always interested in 3 things. The 2 most important are my number of trials and the probability. These are called parameters. These are the parameters that go in, okay, that don't change. This is what you need to find. And you need to find these, and then you need to answer questions. And the questions give the x values, which is the number of successes in those n trials. Okay, so they say the mean and standard deviation. So they found the teen research found that 30% of teen consumers, okay, receive their money from part-time jobs. Okay, so this would be 0.3 out of 215. Okay, what is the expected number of team members that receive their spending? So these 215, how many do we expect? So that would be, this is the notation, or this is the notation. Okay, it's 215 times 0.3. Okay. Or not, yeah, 0.3, that's right. So we expect about 64 to 65. About 64 or 65. Okay? What is the standard deviation? This is a formula. If you guys have a formula sheet, that's good. If not, well, I'll probably put the formula sheet up there for you. 1 minus p. Okay? So this is NP 1 minus p. So I think that was 64.5 was my n by p. 1 minus p is 70%. Because look at, if p is 0.3, that's a success. This is the probability of success. So the probability of a failure would be 0.7, which is just 1 minus 0.3. Okay, so run that number in your calculator and that's what you get. Would it be unusual to see 90 teens? Okay, so this is what you have to do. You take your 64.5, okay, and you add this number. Okay, so let's see if I have that on here. Is there a root on there? Okay, well that's loading up. Let's see how long it's going to take. Okay, so let's pull my calculator in. Okay, so here we go. So I want to take the root of 64.5 times 0.7 and enter. So this number is 6.719. Okay, so what I want to do is multiply this number by 2. That's 2 standard deviations away. So I'm going to multiply this by 2. Okay, and then I'm going to add 64.5. Then I'm going to compare this number to 90. Okay, because what I did was this is what I did. We did this before. If this is 64.5, okay, anything over here is unusual, more than 2 standard deviations. So I do 64.5 plus 2 times 6.719. Well, this number came out to be 77, which is somewhere over here. Or, wait a second, I'm sorry. Which is actually right here. That's where it fell. Let me get a color that you can see. That fell right here. This is 77. Let's just say 78. And then where's 90? Is 90 in this? Is 90 in the rejection region? Is 90 in the unusual region? Yes. Yes, it is unusual to see 90 because 90 is more than 2 standard deviations away. It's more than 2 of these away. Okay? So that's that. Okay, Poisson distribution. For the Poisson distribution, you have to make sure you get the average, okay, in the same units as the x units that we're interested in. Okay, so approximately 2% of people in a room of 200 people are left-handed. Find the following probabilities. Okay? All right. Hold on. That's part 1 right there. Hopefully it uploads. Okay, x units is the same. So I have this problem I just noticed isn't a it's not a this is a binomial. Sorry. They say Poisson. I'll give you a Poisson. This is a binomial. Okay? Because we're not talking about time. If you remember we did binomials or something with time. It's like the probability within a certain time frame. Okay? This is binomial. Okay? Because this is 200 people. 200 people. Okay, so my n is 200. The probability of a success is a lefty, is 2%. Okay? So the probability of failure, which would be a right-hander, is, let me put righty and lefty so you don't get too confused. So the probability of a lefty equals, this is binomial, probability of lefty is 0.02. Okay, so I have my n and my p. That's my n and my p. Now I just have to answer the questions. What's the probability of x equals to 5? What's the probability that there is at least 8? what's the probability that there is less than 2? Okay, so to do this, we go to our stat crunch. Okay, go to our stat crunch. Okay, go stat, calculators, binomial. This is the important thing. That's the other one I had. Okay, how many people did I have? I had 200 people. There are 0.02, and then you just put these things in. Equals 5. That's it right there. That's it. Wish there was a way I could keep this on top, but I could just go back to it. Okay, so it's about a 16% chance. 0.157. Okay? Let's go back to our stat crunch. Not that one. Here we go. Okay? Back, and you just do this for all of them. I have my parameters in already. Oh, wait, this should be 0.02. Sorry about that. Let's make sure I did this right. This should be 200. Yeah, okay. There's that, so that was right. Okay, so I need to just change this to an 8, and I need to change the sign to a greater than equal to. So there's about a 5% chance. Okay, 5%. 5% chance, and you could just do that one. So a Poisson, which would be the last thing that we do, I'll say something like this. I'm going to say on average, a grocery worker could see 15 customers per half an hour, per 30 minutes. 15 customers per 30 minutes. Okay? Then I'm going to say find the probability that the worker will see greater than 35 customers. Customers per hour. Now remember, for Poisson, the average has to be the same as the x average. These two averages, these two means have to be the same. They have to be the same. So if you see, see, I'm asking per hour, but I gave you per 30 minutes. Okay? So if the average is 15 customers for 30 minutes, what is it per hour? If it's 15 per 30 minutes, the mu would be 30 per hour. So now I'm looking for x is greater than 35 per hour. That's all you need. These are the two things that you need. Okay? You need a mu and an x. Let's go back to our stat crunch. Okay, so we go stat. We make this smaller here. We go to our stat, go to our calculators, go to our Poisson. Our mean is, we want 30, you can see 30, and we need to see greater than 35. Hey, that's a coincidence. It's not the same. I was just saying it's a coincidence because this is one we did earlier, 0.15738. It's pretty close. Okay, so the probability of this would be that. Okay, so that's it for the review. Play with these things and go back, read the book, study, and good luck on Monday.